Hello. So yesterday I managed to build a JLL package for this C library called just one second. So this library called Cuba, which is a library in C for doing multidimensional numerical integration. And so yes, I maintain a Julia wrapper for this library, but so far I'm just using a plain simple script based on binary provider to download the binary tarbles. So since yesterday again I managed to build this Cuba JLL package, I want now to use this JLL in the Julia wrapper. So let's start from inspecting the content of the JLL package. So JLL package is just a regular Julia package. Usually we have these JLL packages under the Julia binary wrappers organization on GitHub. So this package again is a regular Julia package which has in particular an artifacts.toml file, which is all the information about how to download a specific tarball corresponding to a given platform. So for example here we have the 32 bits Linux with a muzzle C library. There are also some hashes to make sure that the file, the tarball, is downloaded correctly and also unpacked correctly. Then if you go to the source directory of the JLL package, the entry point is this Cuba JLL.jl. It's a bit verbose, the name. So first of all, the JLL packages can only be used with Julia version 1.3 and onwards. So if you try to use with a version before 1.3, you get an error because the infrastructure of these artifacts has been introduced in Julia 1.3. Then what this package does is to read the artifacts.toml file, get the list of all the artifacts and all the platforms specified in the listed in the artifacts file. Some other operations, and here the JLL package is trying to guess what's the best platform for the user. So based on what is the real platform where this package is running, it will try to find the platform listed in the artifacts.toml file that is matching, that is best matching the current platform. So if it can't find anything, it will return nothing, and so you'll get a message saying, a debug message saying that it was unable to load the platform, to find a corresponding tarball for the given platform. Otherwise, it will include the wrapper corresponding to this platform. So here we have the directory called the wrappers, inside which there are some files, each of those corresponding to a given platform. They're almost all of them the same, with just some small differences based on platform specific details. So I will look in particular into this file because it's the one corresponding to my platform. So what this wrapper does is to export this variable libcuba. If you remember, I mentioned, let me see, Yggdrasil. So if you remember how a build turbals file is made, there is here the list of products. You can have multiple products. In this case, I have only one product. And so this one is specifying this libcuba product. The first argument is the name of the file. The second argument is the name of the variable in the wrapper, and it's this one. So this name, libcuba, comes from this one. Okay. And we will see in a second what this libcuba is. So here there are some definitions of some variables. Here is the path of the libcuba shared library within the tarball. And then here it is. Libcuba is this one. Is the name of the file of the shared library. And so this will be actually what you will use in a C-call from Julia. When you do C-call, you will use as argument this libcuba variable from this package. And this is exported, so you just need to do using a cuba_JLL, and this will be brought to the scope. And then this wrapper at init time, so every time that this package is run, is used basically, it will define this artifact dir variable, which holds the path to the artifact on the disk. And then it will, okay, these are some details. It's accumulating some path to the libpath variable, which, for example, on Linux is this one, is LD library path, which needs to be set when you want, for example, to run an executable, depending on Cuba, if this is the case. But yeah, these are some details that for the general use it's not very important. And then here it is. So here there is the DL open, so it's opening the shared library, the dynamic library, using the full path of the library and passing the return value of this function to the libcuba handle. So this will this variable will have the address in memory, the pointer of the shared library that has been DL opened. And that's it. Just some other initialization of these variables. So this is the most important probably thing to keep in mind, that the init function is DL opening the library. So this is done at every time that you do using in a new session that you do using and then a JLL package. That's it. Not much more about the anatomy of a JLL package. So now I want to be able to use this package in my this JLL package in my cuba.jl library. So I go to my editor where I have opened my cuba.jl. Let me check that it is updated. Okay. So as it is now, this is including this deps.jl file that has been generated by a binary provider. So I don't want to do this anymore, so I can just remove this line. and I will just add the line using Cuba underscore JLL. But in order to be able to use Cuba.jll, I need to import this library in my project. Let's see, the project.toml file. So here the dependencies all include libdl, linear algebra, and binary provider. But I need now to add also Cuba JLL underscore JLL. So what I'll do is to enter the package manager mode, activate my Cuba environment, which is this one. So now I will remove libdl because actually I don't need it anymore, and remove also binary provider because I don't want to use binary provider anymore. And we need now to add Cuba JLL. So now what this is doing is to update the list of dependencies in this file. So if I update it, yes, so libdl and binary provider disappeared, and instead Cuba JLL is here, and I can do I think it's 4.2 the version. So here I also specified the compatibility versions of the dependencies. So linear algebra is a standard library, so we don't need to specify the minimum version. But I get to say that now we require Julia 1.3 at least. Instead, the Cuba JLL version should be 4.2. Yes, this is the version that we have built. It's here, or you can see also in the project.toml file. Yes, the version is 4.2. So now let's go back to the editor. So yes, now we have Cuba, JLL, and Julia as compat, and the dependencies Cuba, JLL, and linear algebra. So now let's go back to the source of the package. And yes, I have added using Cuba, JLL. And I want to remove the content of the deps directory. So what I will do, I will run the command git rm -f deps. Right, it's a directory, so rf. Okay. So let's see now. There should be a SQL here, which is reading. For example, this one is calling the Cuba course function from the libcuba variable, which is actually the same name as the variable exported from Cuba JLL. So if we go to the terminal, we can already try to just run the test of the Cuba package and see if they work. No, okay, there is an error because probably it didn't remove enough. Yeah, so line 1 to 2. Yes, so in the init function of Cuba.jl I still had some function, this check deps, that was from binary provider, but I don't need this anymore, so I can just remove this line and try to run again the tests. Another error. This is interesting. So let's see what's happening. So mcube should be this variable, right? Oh, okay. So this variable is not exporting the symbols that I needed. This is fun. So the error message here is saying that it can't find the symbol Cuba course inside the shared library. So this nm utility returns the list of all the symbols provided by this shared library, and in fact there is no Cuba course. So this means that what I did yesterday was not enough. And so I can't use the the JLL package because it's incomplete. Okay, so let's debug. So what I'm doing now is to try to build again the Cuba library, but I want to enter into the shell during the building, and to do this I need to fail at some point, so that when I use the debug flag, as we have seen yesterday, it will drop me into yeah, Scott is saying that yes, saying that now I got an error, and this is probably more useful than things that just works, because yeah, it's more useful to see what to do when something goes wrong. So yes, now I'm trying to build again the library and see why it's failing. I'm already here, so I can run the bug, for example, for Linux GNU. And we'll see what's happening. Okay, so since I have added this line false here in the script, now it's failing at this point, and so I can see what's happening. So I've generated this libcuba.so file, the shared library, which however apparently it's incomplete. Because if I do nm of libcuba.so, I will see the few symbols that we have seen here as well, because it's basically the same style. So what make is doing is to generate the shared library out of the static one. I don't know if I can see the symbols. Yes. So for example, Cuba course should be in one of these files. Yeah, exactly. Okay. So it's probably not doing what it should. So I think that basically the command that it's running, let's see. Yeah, the command that it's running to generate the shared library is this one, but it may not be sufficient. I need to double check one thing. Let me see. So if I do this, okay, but probably I need to add some extra arguments like this, this. Okay, no, sorry, this is Cuba. That is so. Yes. Okay, so there was an error in my. Yes, perfect. So there was an error in the build script of this package, of the upstream package. So again, what it was doing was to run, of course, in Cuba, was to run this command, but this command is not actually using all the functions defined in the libcuba.a static archive, but we can fix it by running this command using these extra flags. What is it? This one, sorry. So this is saying that to the linker to use all the symbols in this static archive, but not all the symbols, only those needed by the math library LM. So this is not using the whole archive, but it's using the whole archive for libcuba. Okay, so now I need to fix the builder basically, which means actually to fix this one. So I also maintain the makefile. I made a mistake yesterday in the makefile, and I need to find the shared object. So this was wrong. I need to copy this here, and this here. Okay, so I can save, like, fix compilation of shared library. So now I need to update the JLL package. So I'm using the git So here in the recipe used in Yggdrasil, you need to change the revision of the Git repository, and I took the revision from the commit that I've just made and pushed. So here there is so this is the URL of the Git repository, and the second line is the Git revision. So now hopefully it should just work. I can create a new branch. We'll call fix Cuba. Date to fix compilation of shared library. I'm pushing to Yggdrasil my changes, so now I will go to Yggdrasil. Maybe I can show. Okay. So now I'm here in Yggdrasil. I can open a new pull request from my fork. Fix Cuba. Okay. Let me just remove this line. Okay. So the only change that I made basically in this pull request that I'm going to open is just to change the revision used, because I just fixed the makefile. So I can create a new pull request, and that's it. So now you can also see live the building. I'm using Emacs as a text editor. Someone asked me what editor I'm using. So yes, now I open the pull request to Yggdrasil, and it's starting the building that we can follow here on Azure. So in Azure we have these 4 steps. Generator is collecting all the files that have been modified by the open pull request and determining for which JLL packages is going to start the building. So here it found only Cuba, and so now you will see that it's going to generate all the jobs for Cuba in a few seconds. So this is only needed when we create a new JLL package, this JLL init job. And yeah, now you see all the different jobs for all the platforms. Maybe if I go back, you can see better here. Yes. So this list of jobs has been automatically generated by the generator job. So it's very convenient, because in this way we can dynamically generate the list of jobs that we want to run on our CI infrastructure. It's very powerful. And yeah, so now it's building for all these platforms. We have, I think, 8 parallel jobs. We can follow, for example, the first one. It's already finished actually. Okay. It's very fast to compile, to build. Yeah, so everything is fine. So it's almost all green. So now we also have this nice overview of all the warnings issued during the building. So this one in particular is about the fact that the shared library at the end of the compilation was actually found under the lib directory. But as I said in the last live, the shared libraries for Windows must be under the bin directory. But Binary Builder is automatically moving the shared library under bin. There is one error. Right. Yes. So yes. So what happened here? I can show again. I made a mistake because the argument whole archive is not available on macOS. So I shouldn't have used it on macOS. I have a couple of options to fix this. So let's go back to the editor. So here I'm again on the make file of Cuba. But within the make file, I don't think that I know what's the current operating system. So I think that I need to do this in the configure. File, because I should have the information here. Okay, so here we know what's the operating system. Okay. But I need to check what's the argument on macOS, because I don't remember if there is a specific argument for the whole archive. Okay, what I can do actually in the terminal is to fail again here. Well, it will fail anyway, so I can run the builder for Darwin. Okay, so I can run locally and see what's happening. Yes, I think that the live is more interesting than what I was planning, because you can see what happens, errors, problems. You have to fix and think about how to fix these problems. So now it's building for macOS. Okay, so it failed. Let's see again what was the command that it was trying to run. Okay, so this is the command. So I want to see if I just remove this. But this is also misplaced. Yes, so this is not great. So I just run this command without the whole archive argument, but it's not basically building anything useful, because when I do nm no, should be I never remember the arguments of a tool. So a tool is a tool for macOS to inspect the object files for macOS. No, it's not a P maybe. No. Printer header. So okay, nm should work. Okay. No, just nm should be fine. But it doesn't find anything useful. So let me see. Okay. So we should have something similar in Yggdrasil already. Well, let me use this one to search. So archive is for all the build turbos.jl. Yes. So I think that there are some other packages doing the same. Yes, like this one. Oh lot, okay, I see. To be honest, I think that the easiest thing to do is to fix this in the build script. We can do so. Okay, extra. I don't need any extra. So what I'm doing here now is to not use the shared target of the makefile, but build on my own the shared library, because this rule will just build a static archive. Yes, so I can reuse this snippet to just do shared. You can see the editor, yes. Build the shared library and install it. Okay. So I'm creating the libdir directory if it doesn't exist already. And I can do what? Can do libdir libcuba.dlxt using as first flags all load libcuba.a and then no all load. So I should have fixed the configure script or the makefile maybe in the Cuba library, but I think it's just easier to build the shared library directly here. It's just faster. Okay, so now we'll try again to run the builder for macOS. And we see if it works. So again, what is these few lines? What these few lines are doing is to set the different flags depending on the operating system. So for macOS it will be all load and no load, and for the rest will be whole archive, no whole archive. Yeah, let's see. Okay, it failed. Okay, so I have no idea why the general target is failing. So I think that I will fix. Yeah, it's a bit annoying honestly, but yeah. I think I will fix directly the configure and the makefile upstream. It's better anyway. So in the configure AC, I will define these extra variables all load equal to this, and whoops, no, all load equal to this, and the same all load equal to whole archive, no, all load equal to okay. So I think that I fixed these definitions in the configure script, but now I need to update also the make file. Wait, I also need yes to do this. Oops. No. So these macros in the configure script are saying that you need to this will substitute the value of these variables into the make file, so that in the shared no. In the shared object rule, I should be able to use all load and no all load. Okay, I think that now this should be fixed, definitely. So let's review the changes that I made in the configure script. It's yes, so all load, the variable all load and all load are these for Darwin, and the whole archive and no whole archive for the rest of the operating systems. And we're substituting these values in the make file, and we are using these variables in the make file. Okay, so I think this now should really be fixed. So I can say really fix compilation of shared library, or maybe a more meaningful commit message like use proper arguments to library. Okay, so I can push again and use the commit version, the git revision here. So I will test first locally and then I will push again to Yggdrasil. So let's stop. This is the final solution for this problem. Yeah, actually I could have tested directly in the environment before, but I was more or less confident of what I was doing. In fact, it's failing. Great. And it's failing because it's not substituting the variables, yeah. So I did something completely wrong. Right. Right, makes sense. So, yes, I can show you here. So what I did was to modify the configure.ac script, but that one is then used to should be used to generate the configure script with the auto reconf. Yes, so now it should work. Let me remove the make file. Well, I need to run also configure again. Yes, so what I did in the upstream package was to modify the configure.ac script, but I also need to regenerate the configure script and run it again. So I forgot to rerun autoreconf, and I should do it. No, a lot is wrong. So what if I do without? Okay, I can just should be possible to just remove that one. For example, Cuba course. Okay, so when you see in the output of NM, when you see U, it means that the symbol is undefined. But this is fine in this case because these symbols, these functions are actually defined in some system libraries. Yeah, for example, XP2, XP are from the system math library, LDXP, these functions. So what's important is that these Cuba course function, for example, are really defined. So there is not a U, it's a T. So this should be fine, I think. Even let me check. Okay, these are the same symbols here. Cube course. Yes, okay, fine. Okay, so what I need to do is to go to repo Cuba and run here auto reconf. Okay, so that here I will see that these files has been modified. I will stage the changes and commit. And so now again. Ah, no, wait, but we saw, yes. Configure AC. That we can just remove this one. We can make it empty. Okay. So this should work now. Maybe. Too many errors. Build cube. Okay. Okay, let's see if this one finally works. Okay. This one was finally successful, and now I can show you. Oh, that's annoying. So I have some problems with my GNOME system, desktop environment. So I don't know why when I run GNOME, compilation stops working at this point. But okay, anyway, I know that it's working. So I can update this and send to Yggdrasil, push the changes to Yggdrasil. So now we switch to the browser and see how it goes. Let me show the browser. Okay. Okay, yes, so now the change is only fine, the change in the revision here. Oh, okay, so now there is the new job. Okay, so it's now generating again the list of all these build jobs. And hopefully now this will work for all the platforms. I hope so. So I hope that you are enjoying my experience of facing errors and banging my head about what I did wrong and how to fix it. This is basically what I do all the time. So now compilation should be reasonably fast because in Unique Drizzle we use Ccache, which is a system to cache compilation, so to make compilation faster after you compile. Of course, I did something wrong again. It's not that I did something wrong, it's that by regenerating yes. Okay, so here is another detail of so we don't allow the use, I don't know if you can see, so we don't allow in Yggdrasil the use of these unsafe flags when compiling, so dash o fast, dash ff fast math, or f unsafe math optimizations, because as the names say, they are unsafe. And so you can actually have some problems when running this, when running a library that has been compiled with one of these flags. So I removed this one from the configure.ac. So now I will need again to run autoconf and push again. So actually, I think that I removed these variables yesterday, but probably I did it, yeah. I removed this fast math already yesterday, but from the configure script. So when I run autoconf, configure has been overwritten, so the change to configure here was gone. So I had to fix actually in the configure.ac script. Okay, so really remove unsafe optimization flag. Once again. So now let me try here, maybe. Actually, yeah, okay, I will try for this one. Ah, sorry, you didn't see because I had the browser yet. So the problem was that here in the configure AC there was this F -F fastmath optimization flag. So what I did was just to remove this flag, regenerate, then configure script with autoreconf so that this flag was also removed from the configure script. So let's see if this attempt is now working. No. What? Why it's working? What? So we entered the debug shell because there was an error, but if I try to run the command, it doesn't fail. So what? Okay, this is interesting. So if I do make clean or make this clean, run configure again. Okay. So maybe this can be a problem with the parallel building. Right, I need to run configure again. Very few times it happens that parallel building is a problem. Yeah, okay, fine. So we'll just remove the parallel building. So let's try again from scratch. So probably what happened is that I don't know, some rules in the make file are not run in the correct order, and yeah, and so when running in parallel, so there is like a race condition. So here it's not a big problem because anyway compilation is reasonably fast. But in general, when possible, we try to use the parallel building because it makes compilation, of course, much faster. Yeah, luckily we use Ccache, so anyway it's fast enough. Okay, so this was successful. So this will probably fail to create the tarball for me, yes, because my problems. But anyway, it was successful. So let me try for a different platform. And if it is working, I can push again once more. Oh, Uh, okay, I will never finish to fix this mess. Yes, so these flags are wrong. This should be minus WL and minus WL. Yes, because these flags are passing these flags to the linker. So this is what dash WL stands for. So these are not arguments for the compiler itself, but for the linker. So now I have again to go here. Okay. Of course, now I need once more to regenerate the configure script. And push again. Fix flags for the linker. So now I can try. No, where is it? Build the cube. I can try again and again. Okay. Yeah, this was successful. Okay, now this will fail, but I don't care. So I wanted to try for Windows. And now, if this works, I will finally push again to Yggdrasil. So yes, this is taking much longer than what I was hoping. I hope that you are enjoying and learning. Okay, yes. Okay, so now let's go back to the browser. Okay, so these are the changes that I expect. So the change in the revision and the compilation is not parallel anymore, but we tested locally for 3 different platforms. So it should be working. Okay, so now the jobs for the different platforms has been created, and hopefully it shouldn't take more than like 2 or 3 minutes at most. So I'm also lucky that there is no queue this afternoon for me here in Yggdrasil, because sometimes when there is one building LLVM, that one takes a few hours. So I don't have to wait now. Okay, so much green now. And hopefully also the macOS build will work. Yes, okay. Okay, we are getting there. Okay. Okay, let's wait for the last job to finish. Okay, it's all green. There are only, I think, a couple of warnings. These are the same size as before, about the shared libraries for Windows that are not in bin but they're in lib. But it's fine because we know that are automatically moved. Okay, so now I can finally merge. And then we will see here again. And there is a new job that will publish the changes in the wrapper, in this one, in the JLL package. So it is now again generating the job, but this is actually using the cache system that Elliot set up a few weeks ago. So after we build the tarballs, they are uploaded to AWS. And this is also checking if they're already available on AWS. And yes, okay, let me see. It was too fast. So yes, it found the tarballs for all the platforms on AWS. So it's basically going to skip the build jobs for all these platforms. And it will go directly to registration. So JLL init is just checking that this repository already exists. So it won't do much actually, just checking that it's there. And yes, the build job will be skipped, and we will go directly to registration, which will upload the turbles that we've built before. It will upload the turbles here to this repository. It will create a new release and update the artifacts.toml file so that these URLs will point to the new release, and also update the hashes. This should take a minute or two. So also, yes, it will create actually the what? Okay. So it's going to create also the pull request here to the registry. So now it's creating all the JLL wrappers for all the platforms. It's uploading all the turbles. And that's it. Yeah, it created the pull request. So if I update, it should appear in a few seconds. Yes. So you see now in the registry there is the new pull request created by this bot JL build. But okay, so we have a problem with Travis, which is under maintenance. No, I think it's travis.com. Yeah, we will see. Because if we can't merge, no, actually I can test locally without waiting to build. I can check out this version in the registry. So we can go to the registries, general, readme. So now we'll check out the revision. This one, yes. So that I can test at least locally. Okay. So let's see if this finally works. Yes. Okay. 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 1 hour and a half longer than what I was hoping for. So let's review again the changes that I made here. So in the project.toml file, I had to remove binary provider and libdl and added Cuba JLL and fixing also the compatibility versions. I just removed all the files under the deps directory, and in cuba.jl I had to use the JLL package and just remove all the other lines that came from binary provider that you had to do. So this is the new framework of the JLL packages. Makes it much easier to handle binary dependencies, because you just do, if it is a regular Julia package, you just use it and that's it. So yeah, sorry for the long travel to get here, but yeah, if you have any other questions about how to upgrade your packages to use JLL packages, I think I will wait a few more minutes to see questions live on Twitch. So let's see. No, Travis is not working at all today. Oh wait, maybe there are some jobs. Let me see. Oh my gosh, there is a very long queue. Okay, yes, I will not be able to see the pull request merged now. Okay, so there are no questions, maybe. Okay, so I think I will stop the streaming now, and thanks for watching, and thanks for staying with me all the time to see all my troubles. Yes, I hope once more it was useful, and yep, thanks, bye bye.